Hello, everyone. D. Alfred Ostrowski here. In this recording, I'm going to be giving a tutorial / demonstration of performing AAVE flash loans. In this case, I'm going to be running it on the Sepolia testnet network. I'm going to be using Amazon EC2 as usual, and I'm going to be relying on the Hardhat console along with using MetaMask as well. So let's get started. I'm assuming nothing else as usual, other than an Amazon account, a PPK key already generated, some access to PuTTY software, and some knowledge of MetaMask. That's pretty much it. So let's get started here. As usual, I'm going to be cut pasting from my GitHub. All of the instructions are going to be presented on the associated GitHub page. Now I'm going through the installation. If you looked at some of the other videos, in particular those closely related to this with forked Ethereum or AAVE in general, this may be a little bit repetitious. I'll try to keep this fast, but I like to have this remain as a comprehensive portion, at least for the time being. That way you can have a workable solution and you can hopefully get up and running within the time period of this video and have a working example. You can bring that to any architecture or variation or use it as a building block for your own application. So I'm starting a C5 instance as usual. Be up and running, and I'm going to have my IP and I can set up my terminal. I'm only going to need one terminal, right? Because I'm running the Sepolia testnet, and I'm just going to run Hardhat console commands to perform almost all my major activities. So I'm going to bring in PuTTY, and we're going to get the show on the road. You could even use the console commands with the console that's built in with AWS. I'm comfortable with PuTTY. I can expand the screen appropriately and shift it around. So I'm a little bit more comfortable with that. Usual no password, bring it in. I'm going to cut paste my command, so I'm going to step through this really quick. And why am I doing this, right? Why I run through these installs, right? Because I want to make sure that everything's working. Tomorrow it may not work, right? We know that, right? You've done a lot of installs or work with new technologies, and it's not due to anyone's mistakes, right? It's just the nature of the business. A lot of these things get updated, deprecated. So when I find an error, I'm going to do my best to try to keep these examples up and running the best I can. If I have to go back and at least modify the documentation to help you through that. Okay, so here I'm going to be using Node 20. I'm updating that. Try to keep that as new as I can without being too new. I could be on the bleeding edge and break things from that perspective as well. Node 20 seems to be working, so I moved up to that. I was working with 14 not too long ago. That just got deprecated. So that's to my point, right? I want to have workable examples that you can go through and explore the basic mechanics of these. And I don't want to make these tutorials too long, that you have quick examples that you could go in through one session and be up and running and start the day not having done a flash loan. At the end of the session, you'll at least have that under your belt, and you can use that as a starting point to expand your knowledge. Just defaulted through that. I just tabbed through that command. And now I have Node is up and running, and I have restarted the system processes. Here I'm going to be installing Ethers.js and a few extra libraries I'm not necessarily going to be using at this point. But there's no purpose in breaking them out, okay, if I'm going to be using them in the future. However, I do want to keep these installs to an absolute minimum. And again, if you're tired of hearing me talk about the installs, just fast forward a couple minutes and we'll be right into directly into the application. So the last thing I'm going to be doing now before Hardhat is installing AAVE libraries. And the .env, I'm not even going to be using that, but it's good best practice. You want to take your system parameters and put it in a .env file for production. We're not doing production here, just playing around using this as a sandbox, getting used to the technologies, and we can blow things up, right? Especially on a testnet or on an Amazon instance. There's no fear of making a big mistake. However, I would encourage you study up on the AWE documentation, understand the terms and conditions, dig deeper into the software, right? Beyond these examples, and leverage that to your purpose of greater understanding. Obviously, I'm not going to learn everything there is to know about flash loans, you know, the 20-minute plus tutorial. So here MPX is downloading and installing Hardhat, a default Java project, to my project directory, git ignore, crash reports, sample dependencies, and away I go. So I want to talk about while that's finishing up here is I'm going to be using, I need some Sepolia testnet ether to deploy my contract. And I get it from Sepolia POW faucet. I'm not going to run through this and take extra time. It's very intuitive. You just plug in one of your addresses. Again, assuming some familiarity with MetaMask, do some mining. It's going to use your computational resources. This works pretty well, okay, compared to other faucets I've used in the past. And it's my biggest contention with this approach in general. And the reason I really recommend that you might want to explore forked Ethereum mainnet tutorial over this. This is a nice compliment, but I do prefer that because I get my testing resources a lot easier. I can use my Hardhat accounts and I can impersonate accounts to most importantly, get my tokens, because the faucet for the token faucet is not reliable with AAVE. Okay, for whatever reason, just recently I have a lot of trouble getting the appropriate resources and getting them recognized in my MetaMask account. So if you have some frustration, I feel the pain. And my recommendation to you would be to go to forked Ethereum, as most people generate tutorials on this are. But I delved into this. I still believe in the testnet for a number of reasons. Among that, I can deploy applications, I can put it on a testnet, and I can hand it over to people and not be running a node. So there's a lot of great utility. Obviously, the resources, if you can get your hands on them, are free. Okay, so there's still a purpose in using that approach. But if you're overly frustrated, in particular getting the token assets, go to forked Ethereum mainnet, and I have a tutorial for that on this site as well. Right, so Hardhat's up and running. I got two major things, and we're going to get into flash loans really quick. First thing I got to do is set up my Hardhat config file using the VI editor. Most people don't, okay, but this is a quick and dirty editor. It's present. It's ubiquitous, right, with Unix installs. And I'm not doing a lot of fancy editing, though I do want to step through, as I usually do, and go through this line by line and step through all of the major points here. So they're not completely filled in, but this is what I'm using for the example, and I'm going to break it down line by line here. Okay. So I'm bringing in the Hardhat toolbox. You may not need that for this particular example, but moving forward, it will be helpful, as well as the .env. So bringing those two libraries under module exports. I'm referencing 8.10 version of Solidity, and the network I'm using Sepolia, as explained earlier. And I have a URL endpoint defined, and I haven't filled it in. Okay, you'll want to go to the appropriate resources to obtain that and get an Infura account and allocate that as appropriate. So I can show you what it should look like. I don't want to show you what the account is, and I'm going to put the resources up here. You're going to want to go to Infura.io, and let me pause that. I'm going to bring it up and be right back. Okay, I'm back. You go to Infura.io. This is documented on my site, right? And you're going to want to create your own account. I already have my own account created. It's pretty intuitive. And as you go in, You want to create a new API key. I have one here. I'm not going to click in because it's going to demonstrate some of my API keys. It's not best practice to show this off. Okay, let me give you just a screenshot of what it looks like if I clicked into that. You're going to see this under my API key under Alfredo. Okay, under Ethereum, and you're not going to want mainnet. Obviously, you're going to want the Sepolia, and I've scratched these out, right? So when you have all the other networks, this is free, okay? So you can use Infura, you can use Alchemy, and that's what I'm using as my URL. This allows me to connect to Sepolia testnet, all right? So I'm going to go off screen. I'm going to pause. I'm going to fill that out after I explain the accounts here. The next line here, I'm defining under accounts, and I've X'd that out. I'm going to put it in the private key. This is not best practice to embed your private key into a Hardhat config. You want to use the .env again. I don't want to burn time on that. Okay, we can explore that at another time, or you can see other resources, how to find the best practices. This is not best practice. This is getting it up and running, get your flash loan within 30 minutes, right? Up and running. And in this case, I go to my MetaMask, and again, I'm assuming some, want to have some familiarity with MetaMask. I bring in my account here, has a tendency of disappearing. So I'm looking at the 2D11 account, and if I click in account 1 and I click on the 3 dots, I get account details, and it'll prompt me for the private key. It's going to ask me for my address, and it'll display that. I don't want to show that to you because someone saw my private key, then they could grab all my assets. I didn't pay anything for these assets, but it's not a good practice at all. If I had real money in there, real Ethereum, someone could take that and take it out of my account. So what am I doing this for? I'm linking my MetaMask account so I can deploy my flash loan contract to Sepolia testnet. So I'm going to spend money 3 ways on this demonstration. That's the first way. I'm going to deploy my smart contract. I need some testnet Ethereum, and I get that from my proof of work contract, right? And I need some money in the account that has the tokens. I'm going to need my token I'm going to get that from AAVE. I'm going to put up the appropriate, and this isn't connecting here at the moment. Again, this is my frustration. Sometimes it doesn't connect. And I can show you what that looks like. Just pull in the amount here, or the actual screenshot of that. I had it off screen. It's going to look like this as I connect. And this is the staging AAVE.com faucet. And I'm pulling that amount. And again, the major frustration here is I can't swap Sepolia testnet. I wish I could for the tokens. It's not allowing me through MetaMask. Maybe if you use another plugin, it might allow you to do that. Okay. And I can't impersonate an account, obviously, because I'm on the testnet. Okay. Unless I forked it, and I want to fork that. If I'm going to fork, I should just fork the Ethereum mainnet, right? So I'm going to fill these out. I'm going to pause out for a second and fill these out appropriately. And I don't want to show them to you because, again, it's not best practice. So we pause out, right back. I'm back. I've updated Hardhat config, and I've updated it with my Infura key information from my own personal Infura account I created for free. Okay, but I want to be sharing that with everyone. I don't want everyone using, as you don't. Okay, you don't want everyone using your own Infura, or you could grab it from Alchemy. You don't want to be using those, passing those credentials out like candy. And I put in my private information. Obviously, I don't want to share private key information for a wallet, test or otherwise. It's just a bad practice. Okay, and for that reason, that .env is kind of left in there as a means of supporting best practice as you move towards doing more of a real production application. So, okay, fine. Let's put it on contract, and we're going to be ready to go. Start working with it. Again, as I mentioned, this is going to happen really fast. I'm going to go to the contracts directory. I'm going to create a new file. I'm going to call it flashloan.sol for solidity. Now, if you've seen my mainnet for Ethereum mainnet tutorial, I'm using the exact same smart contract. And this has been popularized with some of the other online resources we have seen around. Okay, so this is relying on the AAVE base examples here. So let's step through it line by line. For the most part, I'm going to be using Solidity 810, importing 3 major files from the AAVE documentation. Again, it's in your best interest to study the AAVE documentation and dig deeper into these as you spend more time in this area to have a deeper understanding. Obviously, you don't have to have a complete understanding of how the inner workings of their libraries work to get started. But as you move forward, it's your best interest. More is more in this case, right? So I have the definition of simple receiver base, pool address provider, and IERC20. My contract is named Flash Loans. I'm extending through inheritance, right? Flash Loans, simple receiver base. I have an address defined as the owner, and in the constructor, I'm passing in an address and kind of getting a little bit ahead of ourselves. I'm grabbing that address from the AAVE documentation, V3, and there's 2 main addresses from V3 testnet addresses. Again, the URLs in my associated GitHub. Pool address provider, and this is the first contract address. And if I see this, it ends in FF7F. So I want to bookmark that, keep that in mind as we move forward. It's in my documentation, but I want to show you where I got it in case you have problems. You want to go back and double check, make sure they didn't update, or if you're going to, let's say, have a V4 in the future or something of that nature. They also have an index for EU. I'm going to borrow EURS, but it's testable AAVE. Okay, so you just want to search EURS, you're going to get another token contract address. I want to use their address ending in B4658. So I'm going to just keep that in mind as we move forward. So let's finish out the contract. There's not a lot of code. So I'm passing that address. I'm going to, in the constructor, I'm going to say, hey, use the AAVE bank, use the pooled resources from AAVE and not DYDX or some other type of DeFi provider, right? I'm going to send in an address here to assign it to the owner. And then next they have an execute operation. This is a callback that's defined after the amount is received. And it's going to call execute operation. It's going to include asset, amount, premium. Asset is the ERC20 token. So we're not borrowing Ethereum testnet. We are going to borrow ERC20 tokens. That's why you have wrapped Ethereum, right? That is Ethereum that is supported by ERC20 token definition. It allows for higher level of programmability, in this case, when working with DeFi tech protocols, such as Flash Loans. Okay, so that is the asset. That is the type of currency that we're going to be interested in borrowing. And then the amount is obviously, that's going to be the amount. Now, here's the key point here. It's tricky in the amount of decimal places where you're going to be sending in your function call to compared to actually what you're getting. Key point is between the tokens, they're not uniform. So, for example, with USDC, you have to put 6 decimal places to get 1 USDC. I'm borrowing EURS, I put 2 to get 1. So you want to check that out accordingly. And I don't see a comprehensive document that describes all of these together. I may put some of this together if I'm going to be exploring multiple token amounts, but it's something to be careful as you proceed and identify, okay, when you're working with different tokens. The premium is in the same amount. This is the key point, right? When I'm borrowing in EURS or USDC, I need an amount of ERS or USDC or DAI or whatever type of token. I need something in the exact currency to be able to get the loan. I have to pay the premium in the loan. I can't pay the premium in Sepolia testnet Ethereum. I can only get the premium paid in the given token amount. And I get the premium from the testnet faucet as identified in the GitHub. And if you can't get that, then you're not going to get the loan. Okay, so that's something to be aware of. And you have two other parameters, initiator and call data params. These are defaulted through this call, so you don't have to worry too much about it. And so again, this shows my point, amount plus premium. If they were two disparate amounts, if they were, the amount is in ERS and Ethereum, I wouldn't be adding them together. It has to be ERS and ERS. So I need some EURS to do an EURS loan. However small, I still need an amount. And it goes to the approval. This is an indivisible action, right? It's going to happen in one fell swoop. I'm going to do the borrowing and giving it back with the premium. All in one action. It has to be validated as such before it occurs. And debugging, troubleshooting, problems occur. You can just get in a revert error, and they are very unforgiving in terms of revert. It doesn't usually tell you exactly. So this is why it presents this in small digestible chunks. You can break it down, because when you have that type of error, it may not be easily diagnosed, and you're going to have to go through and step through. Am I doing exactly what I'm doing? So here, again, I want to step through these actions and notice the amount of money before and after that are being spent. That way, and tracking it on the Sepolia testnet ether scan to make sure that we absolutely understand what happened and to what amounts and everything that occurred here, right? So this is what's actually going to be called my flash loan. Request flash loan. I'm going to be requesting what type of token, what type of currency. In this case, EURS. Could be DAI, could be USDC, could be wrapped Ethereum, and a given amount. Okay, I'm going to be passing in an address. This is the address of the contract, not the address of an account. So don't confuse the two. When I first deployed, I pulled money from an account. When I perform this operation, I need to pull money from my deployed flash loan, my deployed smart contract, not an account. It passes in the token amount. And again, these two are defaulted. And that's pretty much it. I have a couple other functions here, get balance, withdraw, check for only owner. I'm not relying on those yet. Those will become useful. You start getting applications such as self-liquidation or arbitration, right? Arbitrage. But we're not exploring it here. We're just going to borrow the money, give it back, small premium, and be done with it. Very good. So that wraps up the contract. We're good to go. Okay, we can start to bring up the console and fire this up to play that smart contract. So next up, I'm going to bring up my Hardhat console. Using npx Hardhat -network Sepolia, right? And that's all I need, okay? Anything else I can validate on the Etherscan, the Sepolia Etherscan. And it is the compilation, so I know that my flash loan compiled successfully. I got a couple warnings on those two default parameters, and that's fine. That's to be expected. I'm not worrying about that. So the next thing I'm going to do is just pull in the Hardhat library. Do require Hardhat and pull in an HRE value. We can check that. Again, the beauty of the Hardhat console, I can always pull out the variables and see the output in JSON format, and I can go through any level of validation that I want. Just have that confidence that it really did what it was supposed to do. Let's deploy the contract. Before I do that, one more thing. Remember, when I pulled in that private key account, it was what? It was linked to this specific account, 2D11. And let's recall the exact amount. So I'm going to check before and after. And the amount is 7453. Okay, so I want to remember that as we move forward. 7453. And actually, I could cut paste that or screenshot it. But let me just copy that, and I'm just going to bring up a notepad and make reference of that, so we can double check that later on. So that was the amount of ETH, right? So Sepolia testnet ETH, okay, not to be confused, okay. So So now we can go through the deployment. And I'm just going to cut and paste that file over that line. And let me bring that in here. So we looked at the constructor, and this is the constructor that I'm going to be calling from. Didn't buffer right. Let me get it again. Let's try it here. There we go. So I'm calling deploy contract. And what am I deploying? I'm deploying flash loan, and I'm deploying an address that's passed in that constructor. Remember FF77F. And that is passing in my address pool, address provider, FF7F of the pool address provider from AAVE. Let's deploy the contract. And I can grab the address. I can use the associated method get address and just pass it into a neat variable that I can parameter that I can check. So let's check that out. Okay, let's grab that address and I can punch it into the Sepolia testnet. And I could just do a search on that, paste it in. Like it's running a little bit slow here. I'm going to give it a few more seconds. I'm going to try it again. There we go. 54 seconds ago from 2D11. So you recall that that was the address from my account that I linked through the private key from the Hardhat config. And it gave me a transaction hash, and I loaded in my contract. D94, which I pulled in to search on. And let me grab that amount from, check my amount against the account here just to triple check everything, right? So it updated 7432. Well, what was the last amount? Okay, 7453 if you look down. So 53 to 32. So that nominal amount is taken against the account. So I should be able to know where I'm getting my money from and the amount that's changed. And I can, if I take that transaction fee and I subtract it, then I'm going to get that amount. So that's how I got to that amount. So I have a successfully deployed contract. Pretty confident about that. I can take and I can get all the amount, the values in JSON-based format associated with that as well. Next thing I want to do is set up a means of validating the token amount, because this contract doesn't have any token values assigned to it, right? I don't have any tokens that have been allocated to it yet, so I just created it. Token EURS, and that's an ERC20 token. And I put in this address, B4658. You may recall that was the second address, the B4658. So this is from the AAVE documentation. Not to be confused with just searching a blanket search on Sepolia testnet and under ERS. It's ERS test minimal ERC20 token AAVE. Okay. And I'm going to use that to check my balance. So I can, now I can check against my deployed contract and look at the balance. It's going to be 0, obviously. Okay, so I want a before and after. This is the before. And now I'm going to take the address and I'm going to go to MetaMask where I have ran the faucet. So again, running the AAVE faucet which may or may not work, okay, depending on what day you run it, okay? If you're persistent enough, you're going to be able to run it again. This is the way it looks. This is the way it should look. I'm not going to go through the connection, and it's pretty intuitive. The only problem is sometimes it's down, okay? So again, for that reason, use fork mainnet, okay? If you are having a lot of problems in similar nature that I have experienced, okay? So let me take that contract. And I do have some amount of ERS in my wallet. And I click under tokens, and they gave me 10,000. So I've only done it a few times. I can click in the ERS, and I'm going to do a send. And I'm going to send it to my contract. And I'm only send one. I'm not going to be charged a lot of the token amount, okay? And I'm going to allow that to proceed, do a confirmation. It's not immediate, okay? So you don't want to just run off in 2 seconds and check it. It may not immediately work. Now, another thing you have to keep in mind, remember, I'm spending my money 3 ways. The first way is deploy the contract. I spent that already. We verified that. The second way is I need to spend some Sepolia ETH to send the ERS to my token. Okay, this send operation, I'm just showing you, this costs money too. So that's the second way I'm spending my money. And then the third will be when I request a flash loan, I'm actually using the ERS as my premium, right? So looks like it worked. Took another ERS. I can view that on the Block Explorer as well. It took one ERS. And you can see the token address is the 4658. That's how what I will specify in the loan. And I'm going to BD94 and BD94. That's my contract, right? So now I can check the token balance, and I have 100 shows up. So again, this points to the somewhat confusing aspect in terms of how the internal representation exists in terms of decimal places, okay, between the units of a given currency. So here, this shows up as 100, but I pass in one EURS. But I have an amount in here, and you could try even before doing this, just jump ahead and run the flash loan, and you can see it's not going to work. And then add in the amount, and then it will work, and then you can see what the difference is, right? So now let's do the flash loan. And what am I borrowing? I have 2 parameters. The first parameter is EURS. That's the 4658. So this sends in the 4658, and I'm going to ask for 1, and I'm going to put 2 zeros behind it. That's going to give me the appropriate conversion. Again, they are not same among all tokens. You think that they should be, but they aren't. So be careful with that and validate that on between the wallet transactions and the testnet, because you can confuse yourself, especially if you're working between tokens, right? Do the transaction, and let's take a look. I have a transaction hash. I can punch that into, and again, I have run this sometimes it runs really slow. It could take up to a few minutes or longer to run. See how lucky we are, okay? It'll run. And this seemed to run pretty quick. And it did a transition. So here I have CFD7, and that is my AAVE pool address. And you can check that as such. And the BD94 is the name of the contract. And then I'm going from this two transfers. One is sent to me. That's my contract. And then one, I send it back. I send that back in. So you notice here, when you have a very, very small amount, sometimes it'll fool you and you may be able to get by without allocating it to the contract or think that you're referencing an account. But as you bump it up at higher amounts, it's going to necessitate that premium. Let me do it again. Let me run it again because I can check that balance, and the balance should have diminished, and interestingly, it doesn't diminish. So let's try for 10 ERS. So I got to rename the transaction value here. Let's go for 10, which in this case, I have to add the extra 2 zeros. So it's 1,000. Let's grab the transaction. Search on this. Hopefully it'll come back real quick. I don't have to be waiting for it. It's not as immediate as this. Don't worry about it. Give it a few minutes and come back. If it's an hour, obviously it's too long. See, it's still thinking about it. I don't think I have to pause out. We can wait for it. It should come out appropriately. Thinking, should be done. And in this case, I have a prominent amount and should diminish the amount of tokens on the smart contract. There we go. So 10 and then 10.01 ERS, that's the premium right here. So that's what I wanted to see, right? And if you're getting a larger amount, you're going to borrow $1 million, you're going to need more ERS as your premium, right? And here I'm going from the CFD7 to the D94. That's my contract. And the D94 back to, they gave it to me. I gave it back with the premium. Okay, so I borrowed it, borrowed the amount of 10 ERS, but I did it really quick. I gave it real back with the small premium, right? So I can go back here. Now, if you've seen my mainnet Ethereum tutorial, I can break down the transaction. We can take the transactions and we can break it down in the command line and look at it that way as well. And that's a great exercise. You want to do that against this, but I don't want to repeat that because I've already done that in the Ethereum mainnet, forked the mainnet. So you might want to take a look at that if you haven't looked at it already. But the last thing I want to do is check the balance from this point now. And now instead of 100, it's 99. So that was the amount, and the units are on the mark, right? Because the Sepolia testnet said 0.01, and here it took 1, but 100 really transferred to 1. So I'm looking at an internal representation. So again, don't be confused with the units. It's easy to be confused. It's easy to be confused with the contracts. And as I just shown, if you're borrowing such a small amount, you could fool yourself that perhaps you didn't put it in the right token, or you didn't allocate it in the appropriate fashion. Then you scale it up, it's not working. Okay, it's because it lets you get by at a very, very small amount. It'll let you get by with the flash loan. It's not worried about doing a flash loan for pennies. But if you're going to borrow $1 million, obviously it's going to require a prominent amount, especially if you're running on the mainnet. So that's it. Everything's documented on my GitHub site. Cut, paste, and work your way through. And I hope this helps. Hope you enjoyed it. Thanks for listening. Like and subscribe, and take care. Have a great day. Thanks again. Talk to you soon. Bye now.